Let's solve the following linear inequality. So we'll begin by rewriting our inequality as 1 divided by absolute value of x minus 3. And we'll transpose half to the left hand side. So we'll have negative half less than 0. So we'll combine the two terms. So in the denominator, we have 2 multiplied to absolute value of x minus 3. And in the numerator, we have 2 minus absolute value of x plus 3. Less than 0. So we have 2 plus 3, so that's 5. We have 5 minus absolute value of x divided by 2 times absolute value of x minus 3. Now here, this is less than 0. So here we have a 2 in the denominator. So what we'll do, we'll multiply both sides with 2. And 2 being a positive number, this is not going to affect the inequality symbol. So we have 5 minus absolute value of x divided by absolute value of x minus 3. So this is going to be less than 0. Now if we take negative 1 as the common factor in the numerator, so we have negative multiplied to absolute value of x minus 5 divided by absolute value of x minus 3. So this is less than 0. This time what we'll do, we'll multiply both sides with negative 1, but in doing so, the sign of the inequality is going to change. So that means this will be greater than 0. So this is the linear inequality, which is the simplified form of the original linear inequality. So we'll try to solve this particular inequation. To do that, all we have to do is we are going to make a assumption here. So we'll suppose that let y be equals to the absolute value of x. Then 1 becomes y minus 5 divided by y minus 3. So this is greater than 0. What we'll do, we'll consider critical values. So critical values are defined as those values at which the values of y for which the numerator goes to 0 and the denominator also goes to 0. So we have y equals to 5 and y equals to 3. So these are the two critical values. Now what we'll do, we will consider a number line, and on the number line we'll take 3 and 5, and this divides the number line into 3 regions, 1, 2 and 3. Now what we'll do, we'll consider region number 1. So region number 1, this number line represents the values of y. So in region number 1, we'll consider a value of y which is less than 3. So let's take 0 for simplicity, and we'll substitute this into our expression y minus 5 divided by y minus 3. So this gives us negative 5 over negative 3, which is a positive number. So that means the region 1 is going to be positive for any values of y which is less than 3. Then we come to region number 2. So in region number 2, we'll take a value between 3 and 5. So let's take 4. When we take a 4, so y minus 5, so we'll have 4 minus 5 divided by 4 minus 3. And this is going to give us a negative number. So that means any value taken between 3 and 5 in the region number 2 is going to give us negative. And finally, when we consider a value of y in region number 3, so let's take 10. In that case, we have 10 minus 5 divided by 10 minus 3, which is going to be a positive value. That means in region number 3, we're going to get positive value. Region 2 gives us a negative value, and region 1 gives us a positive value. So we'll have to consider only those region in which y minus 5 divided by y minus 3 is greater than 0. That means this is positive. So that's region 1 and 3. So that means y will take the value less than 3, or y will take the value greater than 5. So this is the region where the given linear inequality, this particular linear inequality, is positive. Now we substitute back y with the original value, which is absolute value of x. We have absolute value of x which is less than 3, or absolute value of x which is greater than 5. Absolute value of x less than 3 simply means that x must lie between negative 3 and positive 3. Or absolute value of x greater than 5, this will have two values. Either it could be greater than 5, x could be greater than 5, or x could be less than negative 5. So we have the solution, but what we'll do, we'll try to write it in interval form. To do that, we'll first consider a number line. So this is the number line that is going to represent the values of x. So here we'll consider the values negative 5, negative 3, positive 3 and positive 5. Now we have x lying between negative 3 and positive 3. So this is going to be one solution. So the endpoints are not included, so I'm using a bubble here. Then we have x greater than 5. So the x greater than 5 means values of x lying to the right of x equals to 5. And x less than 5 means values of x lying to the left of x equals to negative 5. So these are the region where we are getting a solution which satisfies the given or the original linear inequality. So that region will be given by x belongs to the interval -infinity to -5 union -3 to +3 union 5 to infinity.